Hi, let's talk about the last topic of Physical Sciences Paper 1 for grade 12. Now, this topic is the last of the topics, therefore sometimes schools rush through it or not get to it in time. So please pay attention so that we can maximize. It's a topic where you're supposed to get maximum marks. It's straightforward in its applications. Questions are different, but we'll do the different past papers so that you can see the different ways that they try to dribble you so that you can know the content properly and not be afraid of any question. Now, this is the photoelectric effect. So what is the photoelectric effect? It's the effect we see when light of suitable energy, we'll talk about the technicalities, when it shines on a metal surface, it has the ability to remove electrons from the metal surface. And then the movement of those electrons are then converted to electrical current. Remember, we talked about this issue that electricity is the movement of electrons per unit time. So therefore, we're looking at electricity as current is equals to charge, which is now going to be dealt with, divided by change in time. But charge is actually the number of electrons present times the charge per electron. So this is prerequisite. We have it in electrostatics as well as the electric circuits. So please do take note that this is important. This is why these topics came before this one. Now, let's go into this issue. For us to properly understand this, let's talk about the applications. Applications of this is basically solar panels, the generation of electrical energy based on the light. So when light shines, it can give us electricity. Now, to understand it fully well, we need to understand the concept of the dual nature of light. So light has two properties that it has, or it has groups of properties that are wave-like properties and particle-like properties, meaning it's something that you can actually touch. Now, it also has the movement of it, that its movement is based on the wave nature, longitudinal wave nature. So, in the particle nature, we are looking at it as light is actually made up of particles, and these particles are called photons. So photons are the simplest forms of light that together they then give you the light that you are looking at. But this is going to be important because now we will have light can interact with surfaces, which is why you can block light when it tries to move. That is why light moves in a very high speed. But let's look at this issue now, that on the wave nature, it's an issue of in the movement of light. Light has a frequency. Light has frequency. Light has wavelength. We call this one wavelength. Now, together with this, we are going to look at that since this is the particle of a wave nature of light, it means that we can utilize this formula here, where this is the speed of light, this is the frequency of the light, and this is the wavelength of the light, because we've seen that in any wave, this can be explained. Remember, normally the formula is V, let me write it here. Normally the formula is V is equals to F times frequency, where this is the velocity of the wave in question. But now light has a specific speed, and that speed is actually 3 times 10 to the power 8 meters per second. Let's talk about that a bit. What does it mean to say 3 times 10 to the power 8 meters per second? That means that light travels at 300 million meters per second. So it can travel all the way from Cape Town to Cairo in less than a second, way more less than a second. It can travel from Cape Town to Cairo. It can travel from Cape Town to New York. So now you'll start to understand that cartoons that are scientific based, Sonic the Hedgehog, Superman, The Flash, and as storylines, of course, these ones, especially the Flash is, the name itself comes from light, because the Flash is said to travel at this speed of light. So if you travel at this speed, you can move through places before people even blink. So it looks like you're time traveling. When people are moving, you see them as if they are still, because remember, the movement per second that humans make are quite small movements. So that's what we have. We'll come back to that in some other explanation of the applications, but light, dual nature. Wave nature, particle nature. The particle nature is what we are going to dive into in the photoelectrical explanations of things. However, in the calculation, we are going to be focused on the issues of the wave nature of it, because that's where we get numbers that we can actually calculate the amount of electricity, because that's based on the speed of the electrons that will be taken out from the metals. But now we need some technical terminologies so that we can better understand this whole topic. Let's go. Here are the key definitions. Please understand that of all the past papers that have gone by and the past papers to come, you are required to know 3 definitions that you're going to be asked for your 2 marks. Free 2 marks if you just know these definitions. So now, the first one is to deal with the actual photoelectric definition. So what is the definition for photoelectric effect? It is that this is the process whereby electrons are ejected from a metal surface when light of suitable energy is incident on the metal in question. So now the idea is as follows. When we look at a metal, the metal has protons, which is what we know from all particles, all substances that we deal with. Then we also have electrons around the metal. Then here's the idea. Remember that between, let's use our atomic structure. So between any proton and an electron, there will be an electrostatic bond. So there will be an electrostatic bond. Let me make it bigger. There will be an electrostatic bond between the electron and the proton, which means that if anything is trying to steal the electron, it has to come at an energy that is more than their bond energy to break it across. So when the photons of light come onto or shine on the metal, they must knock out the electron, but they can only do that if they have suitable energy, meaning energy more than the bond that these two have. Is that okay? Now, let's look at work function, which goes hand in hand with what we are talking about here. That's the second definition. So work function says that work function, W0 will be the symbol that we use for it, is the minimum energy of incident light required to eject an electron from a metal surface. So it's the minimum energy so that the photoelectric can happen. Meaning, if the light has less energy than this one, no electrons are moving, no electricity, current is not flowing, no photoelectric effect. But if the energy is more than this, then we have enough energy to get the electrons out of the metal and moving. We'll talk about later that they're actually going to move with a kinetic energy that is greater than 0, which then allows us to be having the current flowing. So let's look at the last one, which is related. Threshold frequency. Threshold frequency is the minimum frequency. So this one is the minimum. We should be having it as minimum. So it's the minimum frequency of light. So minimum frequency of light, incident light required to eject an electron from a metal surface. So these two are actually related to each other in such a way that we will later talk about it, that W0 is equals to HF0. H will be Planck's constant. We'll talk about it later on. But for now, F0 is the minimum frequency, W0 is the minimum energy of the light that falls on the metal that can give us the photoelectric effect. So if the light does not have sufficient energy, all of this does not occur, which means there's no photoelectric. Which is why when the solar panels are there, we will try as much to use metals that have a low bond energy, which means that they have a low threshold, work function and threshold frequency, so that it's easy for the electrons to move out. Because for other metals, it's actually impossible to use sunlight to eject electrons from those particular metals. We need light that is much stronger than sunlight. So that's what we have. Key definitions for photoelectric effect. Let's go now and look at the key photoelectric formula that we're going to be utilizing to explain exactly this, but in numbers.